The first job is to pair the battery frames together. These are the shelves. Makes it easy to connect the battery and make the battery more stable during use. This model will fit the type of battery you need. Its size diameter is 3 millimeters. This is an original factory battery box. Its basic parameters are printed on the box here. This is an iron phosphate battery system. 3.2 volts capacity, 15Ah, 1 cell of TB. Very high quality company standards. Large discharge current and especially very stable. Internal resistance 1.6 milliamp, 1.8 milliamp. Quality of each battery. 1000 tablets the same, no deviation. About voltage and internal resistance. It's not weighing, it's just pulling out and assembling. The price of this product is very high. And now I will give battery into fixed frame. Here, play a 12 volts 150Ah. Use the 4 south system. 10p. I'll sort by the shell that needs to be used. That's how you put the frame and the battery together. Beautiful, aren't you guys? This is solder, zinc. Nickel-plated zinc. And then I'll use a spot welder. Large capacity to connect zinc to battery. Make sure that the welds are the same in terms of quality as well as internal resistance. When we make big models, or we make lots of them, we need to use machines. Good quality is good for welding. I've already shaped the weld marks for what they're going to be. Pre-calculated welds. The first thing is to weld the negative and positive terminals of the battery. Next is the S. If there are 4 S's, it's simple to connect it. It's not complicated. At the top of the cathode and the anode, I'll reinforce the layer to ensure the best flow. Because it's a payload. When the welding is done, now is the time. BM circuit assembly. I'm going to line up a piece of glass to insulate it. And connecting it will be simpler. This is a BM's 4 South 120, a circuit for 3.2 volts batteries. I'm going to use 2 circuits. Add a double-sided tape to fix the circuit and balance wiring. The arrangement of the circuit in what position it fits. Pole of battery housing. From the first black wire, it's going to be on the battery tone, which is called 0 volt. Next to a wire B1, its voltage 3.2 volts. B2 wire is 6.4 volts. B3 wire is 9.6 volts and that last wire is 12 volts. will enter the anode of the battery. This 12 volts battery is also simple, easy to connect, and the characteristics of the iron battery. This is the fire safety factor. It's very high. It is not like Li-ion battery. This battery does not cause explosion. I'm going to turn on a tin torch that I made myself with C245 soldering iron, powered by Makita 18 volts battery. So the first step I'm going to do is I'm going to weld the black A wire, the black B wire. Here's a B1. Next up is the B2. B3. And the B4 wire is the last wire that goes into the anode. 12 volts. Once that is done, I will go check the voltage to see if the balance wiring is correct. When we match the standard voltage into the circuit and through the circuit, it's going to be the same. Here, it's just cathode. It's through the circuit. We'll use it directly. That's it. So the voltage is the same. Two circuits work evenly normally. Now I'm going to weld the load. Then the cathode of the battery will go through the BM circuit. It and the leg B. Here, the wire I'm using is a 10-core AUG wire. Good fire resistance and heat resistance. Line conductivity is also high. And this is the anode, and it discharges directly. It charges and discharges. Also welding 2 points to make sure that there's even current conduction between the batteries. And the last one is the cathode wire, and it's going into the P- leg. Here the circuits are parallel to each other to increase the current conductivity. This is the finished battery that I put in the case and insert the sponge to resist shock. The purpose of this battery pack is to store solar energy. There's a battery light and a voltage bar. 2 strong M8 copper spindles ensure the best current conduction. Jar case with book holder. Everything is beautiful.